Did you know that if you drop Mentos candy into a fresh bottle of Coke, and for the record, Diet Coke works better, the soda will immediately start to fizz and shoot out the top of the bottle as a fountain? I just read that. I didn't make that up. I just read it from your paper. Okay? Physics class hypothesized that dropping more Mentos into the bottle would create a higher stream of soda. The class conducted an experiment with several packages of the candy and 8 2-liter bottles of soda. So here's the data that they collected right here, right? Which group was this? What happened here? And here? Maybe they were absent, or maybe they knocked over their Coke bottles and couldn't figure it out. They were that group. You know what I'm talking about? They were that group, okay? So first of all, let's make a scatter plot of the data. How are we going to do that? Do you remember how to do that in your calculator? Yes, Mrs. Kingston, we sure do. Or, no, Mrs. Kingston, I don't remember how to do that at all. You do remember? Do you mind if I go through it just in case there are people who don't remember? Okay, so we need a new document. Let me zoom in real quick. We need a new document that is, if you know, tell me what it is. Perfect. Lists and spreadsheets. What do I do once I get to the lists and spreadsheets? First, I want to go up here, right? What do I want to call this? X? We can call it X. We could also call it like the number of Mentos, because that's what it's actually called in the table. But X is fine. What are we going to call this? Y, okay. Or height of the spray, okay. So let's arrow down. Let's put in our X values. What are our X values for this problem? 1, 2, 3, 4. Can I use 5? Why not? Doesn't have a Y value, so I have to skip 5 on my table in my calculator. What about 6? Yes. 7? Nope. No Y value here. And then 8. So once I get those in, I want to come over to my Y column and enter my Y values that go with my corresponding X values. So 1 is 6, 2 is 11, 3 is 14, 4 is 16, 5, I don't have that, so I don't have to worry about that. Then 20, then again 7 I don't have to worry about. 8 is 22. You with me? Okay, now that I have everything in the calculator, all my data in the calculator, what do? I want to be able to see it, right? It tells me to make a scatter plot. How do I see the scatter plot? Let's add a page, okay? So Control, the yellow button, Control Doc. What kind of page do I want to add? Oh, a data and statistics. Excellent. Now, yours may or may not look exactly like mine. Does anyone look exactly like mine? No, right? It's just a bunch of random dots on this page. So I need to make them make sense. And I'm going to scoot my cursor over here. See, it says click to add variable. Which variable do I want there? X. That's my x-axis, right? So I'm going to click my X. Ooh, did you see the dots move? Yes. Then I want to scoot my cursor over to the left-hand side of the graph. Click to add or enter variable, and I want to choose Y. What characteristics of the graph indicate that a square root function might create a good model for the data? What do you think? Why might it be a square root function? Caitlin says because it looks like one. Does it look like one to you? Can we always go by looks, though? So what makes it look like a square root function? What's happening right here? It's increasing quickly, but then what happens here? It's still increasing, but not quite as quick. Excellent. Okay? So those are the characteristics that you need to write down right here in this blank. It increases quickly at the beginning. It still increases, but not quite as quickly at the end. Write it. Okay, you have something like that? Yes, oh, okay, okay. Let h of x be the function that approximates the height of the spray, h being in feet, that results from dropping x number of Mentos into a Coke bottle. Okay? So the rule for h of x can be written in this form. H of x equals a times the square root of x, where a is a constant. Determine a value for a that fits this data and tell how you found it. Well, I have this, right? I could use what I already have in my calculator to try to figure out what the value for a is. What ideas do you have? What could we do? If we press menu, what happens? You want to analyze? Okay, so let's analyze the graph. What do you want to do? Regression? Okay. So where's the square root regression? Huh. 4 is quadratic. Is that what we want? Is quadratic and square root the same thing? No, in fact, they're inverses, right? So that may not be the best thing. 5 is a cubic. That means something to the third power. Is that the same thing as square root? 8 exponential. That's where our variable is in our exponent. Is that what we want? Okay, then we can't do that. Let's do this. Let's plot a function. Let's plot a function. So what it gives us is a box right up here. What are we going to put in there? Do you want to, what's the parent function for square root function? Square root of x. Okay. I don't see anything. So when we don't see something on a graph, do we automatically assume we're wrong? Usually, but usually it's not that we're wrong, it's just that we can't see it, right? Maybe our window is not correct. Do we want to change our window? No, we don't, do we? Because this is the important stuff. I want to keep my window right here. So what could I change? I could change my equation. So see how I have a little hand like this? See that? I want to double click it to grab that equation so that I can change something to maybe make it so I could see it. So what about if I made, because see, it's A that we need to change, isn't it? It's A that we need to adjust. What do you think I should put in for A? Oh, okay, 3. We'll put 3 in. What happens when we put 3 in for A? Ooh. Can you see yours now? Okay. Is it right? Is that a good approximation of the data? No? So let's try again. What should we make A this time? What should we make A? 10? Okay. So what do you know? It's too high now. So 3 was too low and 10 was too high. So what do I do? Go to 8? 7? 8? Okay, we're not going to fight. How about 7.5? You both say 8, or some say 8, some say 7. We'll do 7.5. Now that's really good for that point right there, isn't it? Pretty good. But is it good for anything else? Okay. So where should I go? Should I go down to 7 or should I go up to 8? Is that better or worse? Better? Is it good enough? Okay, some of you were saying, yes, it's good enough. Some of you were saying, no, it's not good enough. Okay, if it's good enough, go on. Okay, for those of you who say it's not good enough, what do you mean to put in? $8.5? So that was just slightly too high, right? 8.2? There's 8.2. Okay, we'll go to 7.8. $8.1. What do you think? For those of you who said 8 and went on, I'm not talking to you. Those of you who wanted to get closer, is 8.1 good enough? Or should we try something else? Good enough? All right, so we'll go with 8.1. So let's look back at question number 1. The rule for h of x can be written in this form. H of x equals a times the square root of x, where a is a constant value for a that fits the data. What did we find for a? A was 8.1. Some of you can put 8 because that's where you stopped. Okay. I'm going to go ahead and write 8.1. Tell how you found it. Say again. So we entered an equation on the graph. Whoops. Until what? Until A was close enough? So basically what? Isn't that really what happened? Didn't we guess? Wait a second, this is math. We are never supposed to guess. Oh, wasn't it an educated guess? We guessed 2 at first. 2 was too low. We guessed 10 and 10 was too high. Isn't it logical that we could kind of figure out what it was that way? Is that okay to do sometimes? Yes. The rest of the worksheet I'm going to leave for you to do. Okay? Question number 2, 3, 4, and 5 is your homework. Those are the ones I'm going to leave for you to do. Okay? Let me talk through some of these with you first before I just let you go. With your value for A, use your function rule to estimate a height of the spray for x equals 5 and x equals 7 Mentos. Why do we care about those two x values? Yeah, those are the ones that messed up at the beginning, right? So we may not get their exact measurements, but at least with our approximated A value, can't we get close? Okay. Oh, are we all going to get exactly the same answers on number 2? If some of us used 8 and some of us used 8.1 and some of us used 7.9, things like that, we might get slightly different answers. Is that okay at this point? Yes, okay. With your function rule, estimate how high the soda would shoot out of the bottle if you used 10 Mentos. Why do we care about 10? Yeah, that wasn't something that was tested. We want to make a prediction. We want to find something that was used off the data. Okay? Question number 4, using your function rule, set up and solve an inequality to determine the number of Mentos you'd have to use for the spray to go at least 30 feet in the air And then number 5, using your function rules, set up and solve an equation to estimate the number of mentos required for the spray to reach a height of over 50 feet. Do you think that this is reasonable? Why or why not? Will we all have exactly the same answers when the question is why or why not? Probably not, okay? But you need to have something. Please take the time to go through this. You may work with your partners. You may work quietly with your partners. Okay, your voice doesn't need to be heard over everyone else. Other than that, go ahead and get to work.